Yeah, I'm here.
Welcome. You can
Yeah,
start.
thank you. Uh, thank you very much. This session we have a total 4 presentations. Uh, Hope so. You all are here. There are some co-authors also. So I don't know who is going to present it finally. So first paper is performance evaluation of a non-odorous compost barrel for household purposes. This is M.N. Lunag and J.M.M.M. Boado. So who is going to present this paper?
I'll be the one to present, sir.
Yeah, okay, fine. So then second paper is followed by the hazelnut husk based acclimatization soil for in vitro propagated ornamental plants. This is by S. Ozdemir and M. Ozdemir. Who is going to present this paper? Out of these two author, who is going to present it? Uh, Okay, I think there is no response. Third paper is role of the microbial culture in composting of garden waste. I think that is going to present by the Sandeep.
Yes, sir.
Sandeep, yeah. And the fourth paper is the sensitivity of the SWAT model for soil data parameterization case study in a second stream Turkey. That is by the again multiple authors. So who is going to present this paper? There are 6 authors. Out of 6 authors, who is going to present it? No response. And the last paper is added effect of the methanol organosolver pretreatment on anaerobic digestion of lignocellulosic materials. Again, there are the uh, author and co-authors, and who is going to present this? Okay, so again there is no response. So I request to the first author, first paper author, performance evaluation for a non-odorous compost barrel for household purpose. You are aware about the time limit. So I request you try to finish within a time limit. You can start your presentation.
Hello.
Yeah, I can listen you. Please
Am
go
I
ahead.
audible?
Yeah, clearly audible.
Okay. All right. Good afternoon to everyone, and I'm thankful for the organizers for giving us the opportunity to present in the fifth Eurasia Waste Management Symposium. I am Marcelino Lunag Jr. from St. Louis University, Philippines, and I'm here to present and share to you a study entitled Performance Evaluation of a Non-Odorous Compost Barrel for Household Purposes. So here is the topic outline. I will begin with the introduction and the rationale that leads to the objectives, and I will discuss some materials and methods, and explain also the results and discussion, and finally, I will share to you the conclusion and some recommendations. Am I still audible, sir?
Yeah, audible. Please go ahead.
Okay. So I just want to share where I came from. So came from the Philippines, just in case that you're not aware with the map of the Philippines. It's located in Southeast Asia, and we are located in the northern part of the Philippines. And I just want to share to you our university located on top of the mountain. And so this is our university, and this is our engineering school. So I'm currently taking up a Doctor of Engineering, major in Environmental Engineering, and hope to finish the thesis someday. Okay. So as we all know that the municipal solid waste has different classifications, and in the Philippines, we have the characterization of our municipal solid waste. And we can see here that the residential waste is the largest contributor of our municipal solid waste. And we can see here also that the bio waste is the largest in terms of weight percentage of the municipal solid waste fraction in the Philippines. And it's true for all developing countries, not just the Philippines, but almost all literature talking about developing countries has biodegradable waste as the largest of their municipal solid waste. And so there's a need to really um, solve the problem, because if we solve the problem of bio waste, then we can solve half of the problem for municipal solid waste. Okay. In order to avoid consequences for improper disposal and management of municipal solid waste, we can see here that on this figure, we can see here that this is not a landslide, but it's a garbage slide. Okay. It is natural for us in the highlands that we see landslide, but we can see here that it's garbage which slides on the mountain. And it has a tremendous effect the neighboring um, to the neighborhood, because it destroys several houses and even killed people. Okay, and it causes adverse effect to human health. It pollutes the groundwater. So these are the consequences of improper disposal and management. It's good that in our city, Baguio City, Philippines, we have now segregated our biowaste to non-biodegradable waste. And so the rationale of the objective of the study is that we need to treat the biodegradable waste at source. Okay, since biowaste is the largest, which comes mainly from the residential areas, and as a developing country, we don't have thermal treatment, we don't have the infrastructure. What we can do is a biological treatment known as composting, which is the cheapest technique in the reduction of biowaste at source. And I noticed that in the city of Baguio, because everything is paved by concrete, we don't have available space. And so windrow type or windrow composting method is not applicable. And so I need to find ways or alternative options on how to decompose biowaste. And compost barrel can um, can use up to 1 square meter. So it's a promising decentralized composting approach. But the problem is the odor, which is branded as the Achilles heel in composting. And this is really the problem, because it will hinder household to not pursue composting. And so I've found out that activated carbon, based from related literature, that it can prevent odor. However, very few literatures has been found to use activated carbon matte to prevent odor emission. So there's a need to there's a need of further study of using in situ activated carbon as cover mat soon into fabric to prevent emission from the aeration holes of the compost barrels. So therefore, the study aims to evaluate the compost process inside the composting barrel with the application of the activated carbon as cover mat to mitigate the smelly odor that comes out from the barrel's aeration holes. Now, the other rationale is that according to Calamdad et al., that um, there is a need to have a further comparison between the frequency of turning, the turning rate of the compost barrel, because he suggested that it's daily to ensure a proper decomposition process. Another literature says it's weekly, and another says that it's 3 days. So to fill this gap, I need to compare the daily and weekly turning of compost barrel. So the other objective for this is to determine whether the frequency of turning will have a significant effect on the compost parameters and the physiochemical or the quality byproduct of the yield compost. Okay. So the materials and methods, I need to have a to set up the compost barrel with the activated carbon. So you can see here that the this figure, this is filled with activated carbon sewn into fabric, and it's placed on top of the aeration holes. So inside in the barrel, we have aeration holes here, wherein the activated mat cover can be replaced here to mitigate the smelly odor. So in terms of preparation of compost materials, we need also to set the carbon to nitrogen ratio so that we could be able to establish an initial and active decomposition process. Now, with regards to the experimental analysis, I need to measure the compost parameters. We have the temperature, we have the pH, and the moisture, at different levels of the day. Okay. And in terms of the odor evaluation, there are 7 households which involved in this study, and through Likert scale, I let them rate when we apply the activated carbon, and when we remove the activated carbon, and they rate in terms of the Likert scale. So 0 means no odor, 1 means a very weak odor, which is the threshold based on literature, 1 means weak, and 2 means strong, 3 means very strong, and we have intolerable. Now, in terms of the statistical analysis, I have used paired t-test analysis, okay, using the Microsoft Excel add-ins. Okay. So the results can be seen here. No? So the results in terms of compost parameters, that we have the temperature, pH, moisture, and the mass reduction. Okay, I include mass reduction. So we can see here that compost A, or barrel A and barrel B, have depicted the typical compost stages or decomposition stages, which is the mesophilic stage from ambient temperature up to 40 degrees centigrade. And after beyond 40 degrees centigrade, that would be the thermophilic stage. And then after thermophilic stage will be the cooling stage, wherein it will slowly, the temperature will decrease slowly until it reaches the ambient temperature. And we can see here that on the first week, there's a rapid increase of both barrels in terms of temperature due to the amount of substrates that have met, the amount of substrates which has begun decomposing, and it has reached also the acceptable range of temperature, which is for thermophilic stage, which is 40 to 60 degrees centigrade. Although the ideal temperature should reach up to 55 to 60 in order to kill the pathogens. But the peak temperature for barrel A is 48, while the peak temperature for barrel B is 45. Nevertheless, they fall into the into the acceptable range of thermophilic stage for decomposition process. Now, for barrel A was first harvested after 18 days. This was attributed because barrel A was turned daily, while barrel B was turned weekly. So that is the difference actually. This barrel A was turned daily, barrel B was turned weekly or every week. So due to the daily turning of the barrel, it resulted to more early harvesting time as shown in the figure. And this was supported from existing literature. Now, with regards to pH, on the first week, it resulted into a acidic formation because of the biodegradation of the compost. And after 1 week, it resulted to a neutral pH, and pH has a standard range for decomposition, which is about 5.5 to 7 or to 8.5, I should say. And the result up to the end of the composting process, it falls on the acceptable range of pH. Now for the moisture content, we can see here a gradual decrease of moisture. It starts at an anaerobic condition, 80%, because the ideal moisture content of the composition process should be around 40 to 60%. And it's beyond 60%, so it has an anaerobic decomposition process, which is why we can see here that it's acidic, because it's anaerobic condition. And this also result to foul odor and leachate formations. So, but nevertheless, after 2 weeks, it falls under the ideal range of decomposition process for moisture content. Now, with regards to the mass variation, so there's a significant decrease of mass of barrel A and barrel B, up to 60 to 65%, 65 to 75% decrease of mass, exceeding the expected mass loss according to Diaz, which is around 30 to 45%. Okay. Now, with regards to the odor evaluation, this is the result of the Likert scale. We can see here that there's a significant difference between the application of the activated carbon mat to the without activated carbon mat. And we can see here also that there's a significant difference between the frequency of turning with regards to temperature and pH, meaning that there's an effect of the frequency of turning to temperature and pH, but there's no significant effect to the moisture content, mass, and odor emission respectively. Okay. Now, in terms of the quality of the compost output based from the Philippine National Standard, Compost A and Compost B falls under the soil conditioner because the total NPK for soil conditioner is 2.5 to 5, and it 4.6, we have 4.67 and 4.86. Now, with regards to the carbon to nitrogen ratio, also Compost A and Compost B, barrel A and barrel B have fall under soil conditioner for carbon to nitrogen ratio. At the same time, with moisture content, with regards to color, it is consistent to the standard, and with regards to the odor, it founds no foul odor. Now, the conclusion, okay, these are the key findings that The compost barrel significantly, the usage of compost barrel significantly reduce bio-waste at source and convert it to quality compost byproduct. Now, the physical chemical parameters of the yield compost is in the range of the soil conditioner. Now, moreover, the frequency of turning did not significantly affect the quality of the end compost as long as adequate aeration or five rotation is provided. Also, the turning rate or the frequency of turning, whether weekly or a daily, they significantly affects temperature and pH during the decomposition process. Also, the odor controlling media, which is the activated carbon, soon into fabric, greatly contributes to the reduction of odor and found to be effective in mitigating foul smell during the composting process. So the barrel design in this study can be an alternative composting method suitable for urban areas with limited space and without affecting the adjacent household due to its absorbent features. So this research endeavor showed a humble attempt to evaluate a composting barrel, which can be practical, non-odorous, and eco-friendly solution in bio-waste for household purposes. Okay, I don't know how to, but Ilgenis isin tesikur edris, which means thank you for your kind attention. Often, solution comes from simple ones, and to my mind, composting in our home is an effective and yet simple solution for household bio waste. Tanri Kutsasin. God bless. Thank you. I will now
Okay.
entertain any further questions or clarification.
Yeah. Thank you, Marcelino, for your nice presentation. Now, floor is open for question answer. I request to the other, those who are participating, if you have any query, you can ask from the presenter. Okay, so I think there is no question from other participant or listener. I have a very simple questions related to for when you are turning that drum, are you opening that or without opening, simply you are turning that?
I'm simply turning without opening, sir.
Yeah, because you told there is a no significant difference of the turning, either you have a 1 day interval or weekly interval.
Yes, sir.
That's my response to you, not query. That is the one of the reason, because turning effect is only coming when it is exposed to the atmosphere. So that may be one of the reason you are not finding the significant difference, the role of the turning behavior. Second thing, you yourself is written, it's not a compost, it's a soil conditioner.
Yes, sir.
So that is because I think you have only run the compost barrel for 30 days, total
Yes,
duration
sir.
30. Yeah.
Yes, sir. Because um, after 18 days, the temperature inside the barrel have already in line with the ambient temperature. And according to some literature, it's a sign where you can already harvest for maturation process and replace it again with raw material or substrates.
No, actually, that is the stabilization process, not maturation. If you
Yeah, yeah.
continue that experiment, you can get the good quality of compost, because you have intermittently removed. That's the reason it's not a compost. It's giving the properties of the soil conditioner. Anyway, very good attempt to household level composting. Good luck for you. Thank you very much for your nice presentation.
Thank
Uh,
you, sir.
Now the second presenter, we have a hazelnut husk-based acclimatization soil for in vitro propagated ornamental plants by our, yeah, our presenter is available here. For second,
Özdemir.
paper number 172. Yeah.
Yeah, I am here.
Okay, fine. So yeah, you can start.
Thank you.
Marcelino, you can switch off your video. Okay, fine.
Yeah.
Şimdi paylaşabilirsiniz. Sizi post yaptım.
Just a minute. I'm starting. Can you see my presentation?
No, it is not visible on screen. Maybe
No,
visible
you
in your
must
screen.
click share screen.
Just a minute.
Merve Hanım, ekran paylaşımı share screen'e tıkladıktan sonra orada açılan ekranlardan
Evet,
sunumunuzu
evet
seçebilirsiniz.
biliyorum ama şu an ekranı göremiyorum.
Alt taraftaki share screen bölümü mü gelmiyor?
Evet
Arkada
gelmiyor.
sizin. Bir sizi co-host yaptım ama bir daha bir deneyeyim. Bir dakika.
Normalde zaten sürekli giriyordum, izliyordum ama şu an bir sıkıntı oldu.
Şu an bir daha bir alt tarafa bakar mısınız? Böyle mouse oynattığınızda alttan çıkması gerekiyor.
Hayır, sadece ufak bir siyah ekran çıkıyor. Orada da share screen bölümü yok zaten.
Ekranınızı mı küçülttünüz acaba?
Okey.
Küçük boyutu. Oldu mu? Düzeldi mi?
Sanırım evet.
Tamam.
Şu an bunu paylaşıyorum.
Evet, paylaştınız.
Görebiliyor musun?
Evet, görünüyor.
Go for presentation mode.
Okay. Hello everyone, I'm Merve Özdemir. I'm holding a master's degree at Sakarya University in Environmental Engineering department in Turkey. This presentation is my master's thesis and it belongs to me and my lecturer Sayın Özdemir. First of all, I would like to thank my lecturer Sayın Özdemir for his helping. And our presentation subject is hazelnut husk-based acclimatization soil for in-vitro propagated ornamental plants. A novel substrate was proposed for acclimatization of micropropagated plant species. Survival rates of in-vitro propagated plants are low when they are transferred from vessel culture to ambient environmental conditions. Mortality rate of transplanted plants are generally high due to the environmental stress conditions, including insufficient soil substrate used for acclimatization. In the present study, several ornamental tissue cultured plantlets were transplanted on a novel hazelnut husk substrate in order to test the ability to acclimatize ex vitro conditions. And as a in vitro plants as shown in the figure. In vitro propagation has been extensively used for propagation ornamental plant species due to the rapid multiplication of high quality, precious, rare commercial plants in a laboratory. A substantial number of plantlets don't survive when transferred from in vitro to ex vitro environmental conditions due to the septic environment, lower relative humidity, temperature fluctuation, and insufficient readily available nutrition that are stressful to micropropagated seedling compared to in vitro conditions. In this context, the success of micropropagation not only depends on multiplication in culture media, but also depends on high survival rate and healthy plantness during acclimatization stage. Most plant species require an acclimatization stage in order to ensure a high number of plants survive when transferred to ambient conditions. Different waste organic materials or byproducts have been investigated for fully or partly replacing non-renewable inorganic or peat-based substrates. Cocoa peat, compost, and wood industry waste are some organic materials that are already being tested for possible ornamental growing media. In addition, some growth-stimulating humic-like materials such as leonardite, biochar, clay granules, and vermiculite are used in mixture with peat and other combinations. The main aim of those studies were primarily to decrease the mortality of newly transplanted in vitro plants by either hasten the root and protective cuticular tissue formation to restrict the excess transpiration when plants are transferred from in vitro to ex vitro conditions. The expectation from the hazelnut husk and gidja is a good rooting substrate because hazelnut husk proved to be a good growing media and gidja is a source of growth stimulating substances. And hazelnut husk and gidja as shown in the figure. The in vitro micropropagated test materials, Rosa hybrid, Loropetalum chinense, aloe vera, Hiloserius undatus, they are obtained from the tissue culture laboratory, Sakarya University in Turkey. SEM image of the hazelnut husk proved to be an acceptable porous and relatively smooth surface structure as a main component of the potting soil. And figure 1. And figure 2, EDS analysis of hazelnut husk and elemental compositions of selected spectrum. And table 1, physicochemical properties of hazelnut husk and gidja. Parameters, for example, organic matter for hazelnut husk, approximately 80, and for gidja 60. And for example, ash for hazelnut husk 13, and for gidja 32. The indicator in this, like the germination rate, the relative germination, the relative radical growth, and the seed germination index, calculated the test procedure described by as follows, like this. The study was prepared in a one-way ANOVA experimental design for 4 plant species. The experiment consists of one factor, growing media with a combination of different composition substrate. For example, A0 100% hazelnut husk and A1 99% hazelnut husk plus 1% gidja. Every combination of treatment was 10 replications, so there were 6 treatments for each plant species. The environmental conditions in a chamber was operated with the following conditions: 14 hours light and 10 hours darkness, quantum flux density 200 micromole meter second, and temperature 20 Celsius. Relative humidity was gradually decreased from 90 to 70. Transplanted plants were kept for 4 weeks in an acclimatization chamber, like this, figure 3, and acclimatization conditions. The plant growth parameters calculation of survival rates were performed at the end of the study using a following formula and survival rate. As a result, the response of in vitro plantness of 4 plant species to different growing media is presented in figure 4. The survival rates of plantness on average at the end of the experiment was 96% for Hilarius undatus, 74% for aloe vera, 34% for rosa hybrid, and 16% Loropetalum chinense. A survival rate up to 90% was obtained for the Hilarius undatus for all tested potting soils. And as you can see, Hilarius undatus is the species most suitable for survival acclimatization. In the present study, potting soil mixture prepared by local waste resources were tested for the aiming to rapid rooting and improve survival rate of plantlets of 4 different plant species than that of woody species, rosa hybrid, and Loropetalum chinense. The most important finding was that hazelnut husk derived from agricultural waste stream and gidja derived from mining waste didn't adversely affect the survival rate of in vitro seedlings. However, more information about the physicochemical characteristics of growing media combination would help to establish a more suitable potting soil for possible use in vitro culture acclimatization. And I would like to thank Sakarya University Tissue Culture Laboratory and Professor Dr. Taki Demir for supplying the plantnets, advising us precious information for ex vitro acclimatization and measurements and references. Thank you for your attention.
Thank you very much, Marve, for a nice presentation about what is the role of the acclimatization. Really, role of the acclimatization play a critical role whenever we are switch over from one area, in vitro to ex vitro. Now, this forum is open for questions. If any, those who are attending session, if you have any query, please go ahead. You can ask the question. Okay, so I think there is a no query. I have a one very small query. At one place you have mentioned about the septic environment. Can you explain a little bit what is septic environment?
Septic environment for the plant conditions in environments.
So it's a basically environmental conditions.
Environmental conditions like temperature and pH and light rate, blah blah.
And I think it's a better you can use the environmental conditions. That is the much better way to write down rather than writing the septic. Okay, that's why I'm confused. What is meaning of septic? And another reason you have reduced the humidity from 90% to the 70%. What could be the reason to reduce, and what is the role of that change of 90 to 70%?
Humidity.
Yeah.
Like water balance. If we can reduce the water balance, we can reduce the humidity.
So my question, why you have reduced from 90 to 70? What is the hypothesis behind this?
Excuse me, which slides?
Yeah, it's one place you have mentioned. You have humidity is changed from 90% to the 70%. Yeah, you go ahead. One place it is written. Go next. You have, I think in material methods you have written that conditions. Okay, anyway, leave it. That's my query. Why we 20% variation of humidity? What is the role of that one? Anyway, so thank you very much for your nice presentation. Thanks. And now we have to enter into the next presentations. So next presentation is the role of the microbial culture in composting of the garden waste by Sandeep Mishra. Sandeep, are you available? Yeah. Sandeep, switch on your mic.
Okay, thank you, sir. Thank you so much. I hope my presentation is visible to all of you.
Yeah, it's visible. Please go ahead.
Okay, thank you, sir. Thank you, sir. My name is Sandeep Kumar Mishra. I'm a third year PhD student at SVNIT in Department of Civil Engineering in Surat, Gujarat, India. And it's a pleasure for me to be here to give my presentation of role of microbial culture in composting of garden waste under the guidance of Dr. Kuva D. Yadav, sir. So we will begin with the presentation. Before we go into the presentation, let us have a brief. It is not. Let us have a summary of what exactly we are going to discuss. So basically, we are doing the degradation of garden waste, which occupies a huge portion of municipal solid waste. So we did the composting of garden waste using in-vessel composting, using aerated in-vessel, and the culture that we have used is a food waste culture. And we have done the composting for a period of 45 days, and we have done the physiochemical analysis using C by N ratio, total volatile, carbon dioxide, and at the end of 45 days, we got that the microbial culture of food waste is playing a critical role in the compost maturity, the time, and quality. As we all know that municipal solid waste occupies a huge portion, and garden waste occupies 15 to 18% of the total waste generated, which is a huge number. Some of the major problems of garden waste, uh, basically they are that it is a low density, it is a heterogeneous mixture, and it has a low decomposition rate. Also in India, 1130 million tons per year was the production in 2016, which is a huge number. There are various options for in-vessel composting, and we have gone for aerated in-vessel instead of rotary or other methods, because aerated in-vessel is an efficient reactor, and it provides quick agitation, sufficient aeration, and also proper mixing of waste, and also the time of degradation is drastically reduced. Coming back to the microbial culture, microbial cultures are nothing but microbes or a group of microorganisms that help in rapid degradation of organic waste. Their main role is to multiply rapidly and consume the substrate. Also, they help in increasing the composting rate. Coming back to the other materials and method, we are using garden waste, which is available from a garden in Jawaharlal Nehru Garden present in Surat. The culture that we are using it food waste culture, and the method is in-vessel composting. So this is, as you can see from the figure one, we got garden waste using with the help of a tractor. And as you can see in the B, that is the feedstock. So before using the garden waste, we had to remove all the unnecessary particles like plastic, paper, and we were only using grass, small branches, leaves, and we have removed the woody parts as they're very difficult to degrade. Also, we used a shredder available in our laboratory to shred the garden waste into the size of 1 to 2.5 centimeter for efficient degradation. The garden waste, we did the characterization in our lab with a moisture content of 46% and 38% of total TOC, and it had a C by N of 35. And for the food waste culture, we got the food waste from our boys hostel in the SVNIT laboratory. As you can see from the figure, we used this grinder to grind the food waste into smaller particles. And after using the food waste, we covered it with a polythene sheet so that development of fungus could be taken place. So after 7 days, we take out the plastic and we use 5 liter of water in 5 kg of food waste, and we prepared the culture, and we spread this culture over 50 kg of garden waste for efficient composting. As you can see from the figure table, these are the physiochemical characteristics of the feedstock. We have taken garden waste and food waste culture. The initial C by N was 35 of garden waste and 28 for food waste culture, and the number of samples we took was 3. This is the aerated in vessel in our lab. Basically, one of the major advantages is because of the configuration of the blades as it is visible to you in the figure. So we rotated it using motor for 3 to 5 minutes daily, and we took 500 to 600 grams of sample, and we did the physiochemical analysis. We have used different methods for moisture content, pH, electrical conductivity, ammonical, carbon dioxide evolution, potassium, phosphorus, and volatile solids. This is the flow diagram. So we have collected the waste, we have removed unwanted particles, we have shredded the garden waste, we have feed the garden waste and culture into the reactor, and we have mix, and we did the daily, and did the monitoring of all the parameters. So these are the parameters that we have analyzed: moisture, temperature, pH, EC, TOC, TVC, ammonical nitrogen, ash content, carbon dioxide, among other parameters. So now we'll come back to the result and discussion. We'll first start with the temperature. So for temperature, as you can see, in the second day itself, around 72 to 73 degrees Celsius temperature was observed, which shows that a higher degradation was observed. Also, as you can see from the figure, the thermophilic phase, it continued almost up to 8 days, which helps the composting in proper sanitization of the whole compost. You can see the result and discussion, which is compared with the control. In control, we only took 50 kg of garden waste and we added no culture or no water. Similarly, we did the other physiochemical analysis as it is visible to you, the moisture content and total volatile solids. Moisture content reduction was high during the thermophilic phase, which shows that higher degradation was taking place. Also, total volatile solids is another important compost maturity parameters. So as you can see, initially it was 80, and after 15, 30, or 45 days, at the end, it reduced to 57 percentage, which shows a higher amount of degradation when compared with the control. Similarly, we found total organic carbon and ash content. Total organic carbon, as also it indicates compost maturity, and carbon dioxide evolution from compost led to the decrease of total organic carbon. Similarly, as content, as you can see, it increased. Increases as content is an indicator of higher rate of degradation of garden waste. Initially, it was 16, but after 45 days, it got to 42 percentage. Coming back to other parameters, we also did pH and EC. pH, as it is visible to you, it increased at the starting week due to release of organic acids, and then increased and it moved towards neutral by the end of 45 days. Rotation of garden waste in the reactor, it provides adequate aeration. accountable for the rise in the pH and increased degradation. Similarly, EC is another important indicator, and it's a degree of salinity. Also, it's an indicator of phytotoxicity effect on growth of plant. So the value within 3 of 12, it indicates the compost maturity. Release of mineral salts led to the decomposition of organic matter, which led to the increase in EC. Similarly, we found total nitrogen and ammonical nitrogen. Total nitrogen, concentration of nitrogen as it is visible to you, it increased due to loss of organic matter and due to activity of nitrogen fixing bacteria. And one of the main reason was due to loss of organic matter and due to loss of dry weight. Similarly, for ammonical nitrogen, it is another important indicator of compost maturity. It increased rapidly up to 15 days and then it started stabilizing due to volatilization by microbes and nitrification. The concentration of ammonical nitrogen decreased. Coming back to other important parameters, carbon dioxide evolution rate is another important parameters to check the maturity of the compost. It indicates the readily biodegradable composting material present for the compost. Comparing with the control, as you can see, initially it was 19.5, but it got reduced to 4.2. When compared with the control, it only reduced to 8.7, which shows that when comparing with the control, higher degradation was taking place in the food waste culture of garden waste. Similarly, C by N, as we all know that it is essential, carbon is utilized as a source of energy by microbes and nitrogen is used for building cell structure. So the initial was around 26, but after 45 days, it reduced to 13.6. And the C by N value within 10 to 15, it's an indicator of the compost maturity. As you can see from the figure, when comparing with the control had a C by N value of 20, which shows that it is still not properly degraded. Coming back to another parameters, we did phosphorus and potassium. Phosphorus, it is essential for plant growth. Plants take up phosphorus in soluble forms. It increased due to loss of organic matter. When comparing with control, as it is visible to you, initially it was 1.5, but after 45 days of composting, it increased to 4.8. Similarly, with did the calculation of potassium. Potassium helps in enzyme activation, and it is important in adenosine triphosphate production also. The reason for increase in potassium was due to loss of weight and organic matter degradation. So initially it was 5, and after 45 days, the potassium increased to 9.1 compared with the 6.62 of the control. This is the figure which is showing the observation of food waste culture for initial 15 days, day 30 and day 45. Due to the configuration of plate, the proper degradation was taking place. And finally, this is the changes in the physiochemical of garden waste. We have compared all the parameters with compost parameters, FAI, Fertilizer Association of India, and TMECC test method for the examination of composting and compost. So all the parameters that we got are within the compost standard range. Uh, the C by N was 13.7, the total nitrogen was 2.2, the phosphorus was 4.8, and the CO2 was 4.2. So after the end of 45 days, we found that the study showed that the microbial culture is playing an important role in the degradation of garden waste, by elevating the temperature and also reducing the maturity period. And also, we found after 45 days that the microbial culture is playing a very important role in the compost maturity, time, and quality. Also, these are the references for the future study. We can try different uh, other cultures like uh, uh, cow dung is there, compost is there, so we can do it in for the future. And that is it for the presentation. Thank you so much. And because of some camera problem, I was not able to use the background of EWS Euro Asia. So thank you so much. If anybody has any questions, you can ask. Thank you so much.
Thank you, Sandeep, for presentation. Now floor is open for the question answer. Okay, so I think there is no question. I don't have any question because he's working with me. Now, so the next, we are going to the next paper, paper number 184. That's called the sensitivity of the SWAT model to soil data parameterizations case study in a Sechkarnia stream, Turkey. We have a number of authors in this case. I I request to the author who is going to present it this paper, Mr. Halil.
Hello.
Yeah.
Can you hear me, Chairman?
Please go ahead. Yeah,
Okay,
I can hear you clearly. Please go ahead.
Okay.
Sandeep, can you change it? Yeah.
Okay. Sorry. Hello, Chairman and everyone. I am Halil and I work in Institute of Earth and Marine Science in the Gebze Technical University. First of all, we conduct a study on testing the sensitivity of soil database on hydrological models. The content of the work is mainly, as in the figure, theoretical background, aim of this study, material, method, and result section. Although the general structure of the hydrological cycle is easy to understand and interpret, it's just as difficult to measure and analyze the process in the system. The many physical base models have been developed in the process of the water research with their watershed. The soil and water assessment, after now I will call the SWAT. SWAT is one of the most widely used of these hydrological models. Researchers can be models all hydrological process, such as surface runoff, infiltration, percolation, evapotranspiration, etc. Unfortunately, without the deep aquifer level, recharge deep aquifer level. Although the most important advantage of the SWAT is that having open source software. Thus, all researchers who are interested in hydrological models can assist or develop in the development of this model. Importance of the soil database. Soil physicochemical information is one of the critical inputs needed to assess sensitivity and analyzing the output of the hydrological models. In the Turkey, generally, Turkey's study conducted on the Turkey watersheds related to soil in hydrological model setup. Some parameters such as number of the soil layers, profile depths, organic matter, etc., were generally calculated or accepted according to default values in the literature. However, these values were generally based on the foreign studies and cannot reflect unique characteristics of the studied watershed. For this reason, conducting field and laboratory analysis and literature review to reveal unique soil characteristics throughout of the watershed will enable a more accurate decision about the soil condition of the watershed. Comparing high labor-intensive soil analysis with international soil database, such as Food and Agricultural Organization, FAO, and identify the similarities or differences will help researchers better understand the specific characteristic of the studied watershed. In light of the information, aim of this study, firstly modeling the hydrological process of Çayırova stream were located in northwest parts of the Turkey, and analyzing the soil physicochemical characteristic of the catchment area with laboratory and field studies. Finally, evaluate the effect of FAO and soil database produced from this study on stream flow using SWAT model without applied any calibration technique. Study area is first step in the methodology section. Çayırova stream runs along the Kocaeli-Istanbul border, one of the most important industrial regions of the Turkey. Length of the stream is about 10 kilometers. approximately 2 kilometer length of the stream in Gebze Technical University campus, southwest parts of the watershed. Width of the stream is variated to 20 meters. The catchment area approximately 50 square kilometers. Such stream area is represent 20 square kilometers. The rest of the area is represented Çayırova stream. And the catchment area was classified by small-scale basin by Atasayan et al. Soil data preparation section. As you know, soil structure is a critical factor for understanding processes such as surface runoff, infiltration, etc. According to soil database prepared by Turkey General Directorate of Rural Service, the watershed includes 3 main soil groups: resinas, brown forest soil without lime, and brown soils without lime. In addition, the parameters required for SWAT are limited in the soil database. Thus, field studies and laboratory analyses were carried out to obtain the required parameters for the SWAT. 7 out of the 12 parameters were determined by the laboratory and field studies. Firstly, the analysis of the soil texture, which directly affects other parameters, and their determination was made. After determination, rock particle diameter higher than 2 millimeters, and sand particle diameter range between 2 and 0.5 millimeter percentage by wet sieve analysis. Clay, after that, clay and silt content of soil samples were determined using master sizal Malvern device. According to this percentage, soil texture were determined in the soil texture triangle system. Total organic matter, after that, total organic carbon content was, unit is percentage, was analyzed according to low zone ignition method. This method was validated with the Volkley-Blake method, and the results were consistent. We can see flow charts for running the SWAT model. In the SWAT model setup, digital elevation model, land use map at soil map, and slope definition produced from the digital elevation model map as spatial data for running the SWAT model. So, actually, several methodological parameters are used in the temporal data set. These data are precipitation, maximum and minimum temperature, solar radiation, relative humidity, and wind speed. Meteorological data were obtained from weather stations of Turkish General Directorate of Meteorology, located in the catchment area, Çayırova weather station. In addition, the meteorological data produced by the National Environmental Prediction Center, NCEP, was used, reprojection data. And Turkey General Directorate of Meteorology data were utilized to create files for minimum and maximum daily precipitation and temperature. The rest of the meteorological parameters were simulated by using NCEP, reprojection data. Actually, the obtained data set consists of 4 years, 2016 and 2020 period. In this data set, the first 2 years were used as a warm-up time in order to increase the performance of the model. Digital elevation, we examined the digital elevation model. The elevation of the watershed range from sea level and 311 meters. The variation in elevation are relatively high. This especially affects the amount of the water to surface runoff. Sub-basin, in addition, sub-basin boundaries have been created by considering the flow measurement points. Within the scope of the TÜBİTAK project, the study focused on the substream boundaries networks. Therefore, the 7th sub-basin representing the Çayırova network is not specified for this study. Land use and land cover data was derived from coordination of information on the environment project CORIN, data reflecting the year 2018. The CORIN land cover classification is based on the three-level hierarchical base, and each level corresponds to individual scale. Level 3 mapped on the scale of 100,000 and has information 44 categories. Level 3 corresponds to on the scale of 500,000 and level 1 mapped on the scale 1 million. In this study, level 3 was examined in order to present the land use of the basin straightforwardly. And after that, level 1 class were taken into consideration for the SWAT model. According to the CORIN data set, 73% of the basin consists of built-up lands, industrial and residential area. It's a very high rate. 15% agricultural lands, 10% range lands, and rest of the percentage represent the road and rail networks. Slope class were classified by considering conventional statistical parameters such as first quantile, second quantile mean values in the slope map produced from the digital elevation map model. Preparation of the soil map in order to represent the whole catchment area, 29 soil sampling points were identified. The points were chosen considering main soil group slope depth combination derived from Turkey national soil maps. And land use and land cover map also considering the classification. Soil map were comprised, consider determined soil texture and main soil groups. As a result of the laboratory studies, 3 types of soil texture were determined: sandy loam, sink loam, and the loamy sand. The dominant soil type of the studied area, classified as a chromic soil according to Food and Agricultural Organization soil maps, is defined. Chromic soil means the medium to fine texture, actually sandy loam, and undulating to rolling, and reddish to brown color. Special distribution of the selected soil parameters: soil profile depth, units millimeter, erodibility factor, organic carbon, and clay content. Values were classified using the inverse distance weight interpolation technique on the ArcGIS platform. The maximum profile depth, 900 millimeters, was observed northeast parts of the watershed, when the minimum soil profile depth has lowest value is 250 millimeter in the residential areas. The erodibility factor, high erodibility factor, was calculated in the Çayırova subbasin relative to subbasin. The organic carbon content of the watershed is relatively low compared to other studies, while high carbon content appears in the south parts of the subbasin. Organic carbon contents of the remaining areas generally vary between 0.3 and 1.1%. Lower clay content is observed higher elevation, while the southern part of the watershed has a relatively higher clay content. In addition, soil texture within the catchment area is rich in terms of sand and silt content. Actually, compared to soil database in the table, the depth values in the specified soil database, SSM, were found to almost half of the values given in Food and Agricultural Organization soil database, while soil texture values are almost evenly distributed in the FAO database. About 78% of the SSM, additionally, 5-time differences were observed in the percent clay content values between the two soil databases. HRU definition: HRU, hydrological response units, produce with the fixed input layers and two different soil database are similar. Is two value. As a result of different combination we made in the model setup, it was observed that the most important input layer is slope classification. For example, while 139 HRU was produced in only one slope class definition, approximately 3 times the HRU was produced in the 5 slope classification. The temporal variability of observed and predicted runoff from Food and Agriculture Organization and specified soil map database model outputs were compared for both soil database sets without applying automatic or manual calibration process. Examining uncalibrated model outputs is significant for evolution to predictive performance of the model, because of the fact that calibration process masks differences which can occur as a result of the soil dataset. In another respect, the uncalibrated model outputs represent the runoff estimation performance of the used soil dataset, which is the required effort for calibration. In this study, surface runoff was better estimated by using SSM database and require less effort for calibration process. Runoff values produced from two soil databases were overestimated the observation values. Generated runoff values considering SSM was overestimated compared to runoff values produced using FAO database. In addition, generated runoff from two databases have similar trend. Determination coefficient value, so R square value of the dam was calculated 66%. In seasonal approach, the surface runoff was observed highest in winter season and lowest value were observed in summer season as we expected. In contrast, two episodes were observed in May 2018 and May 2019. While episode 2018 can be explained by industrial and residential discharge over the watershed, episode in the other date can be defined by average monthly precipitation 142 millimeter approximately. And we examine the scatter plot. The proximity of the scatter points, one line, shows the predicted performance of the model. Low runoff values were observed relatively closer to the trend line relative to higher runoff values for both soil database. Determination coefficient, Nash-Huckley coefficient of efficiency NCE value, and root mean square error values were used to evaluate the quality of model results. And the Motolo et al. State that if the NCE value produced after applied calibration process is important in this study without applied any calibration techniques. Sorry. The NC value between two value, the model performance is excellent. The NC value is between the two value, the model performance is acceptable, according to Motolo et al. The NC value calculated in this study, the NC value calculated as the 0.19 and 0.48 for FAO and SSM respectively. In this respect, while the SSM database was making acceptable estimates even before calibration, the found NC value using the FAO database remained below the acceptable threshold values. The conclusion, if we need to discuss our important findings in our study, evolution of SSM, which was comprised of laboratory and field studies, soil texture of the watershed was dominated by sand and silt content. High clay contents were relatively observed in Gebze Technical University campus, which forms the delta of the Çayırova stream. The reason for this result is that stream energy decreased, thereby increasing the tendency of suspended solids to precipitate. The most noticeable differences among both of soil databases is the clay and sand content that change soil texture directly affects the stream flows. And other important findings, the predicted runoff values were overestimated relative to observation runoff values. This situation can be explained by infiltration into the soil, can be diverted by bedrock to the stream because of proximity of the bedrock to the surface in the watershed. High runoff affects the surface flow condition. Low runoff affects the base flow because of increasing infiltration period. In this context, the observed relatively good results for low runoff condition indicates the model prediction performance at the base flow better than the high runoff condition. Actually, in conclusion, relatively homogeneous soil database, such as the FAO database, can be used to provide an overview or to quickly obtain information of the hydrological process in the watersheds, especially under the industrial and the domestic pressure watersheds. However, for detailed scientific analysis, such as watershed management practice or water quality studies to be carried out in like watershed, the soil database of the region should be specified. Thanks for your attention.
Thank you very much, Mr. Halil. Now the forum is open for question answer. If any specific questions by to the presenter by anybody who is attending, please go ahead. Okay, so if there is no question, I have a very one simple question. Because you have taken 4 types of the soil, what is the role of the soil in terms of the sand content? What is your observation?
Sorry, Professor, could you repeat your question?
My question is, you have compared the different type of the soil. You have a study conducted with different type of the soil. Okay.
No. I can't hear you, Professor.
Okay, so
properly.
No issue. So there is some audio problem. Okay, anyway, thank you very much then for nice presentations.
You're welcome, Professor.
So now we are going to the another presentation, the last presentation of this session, that is by the effect of the methanols orgosolvent pre-treatment on anaerobic digestion of the lignocellulose material. It's by the A. Oliva, T. Citan. Okay.
Good morning. Can you see and hear me?
Yeah, we can hear you. So
good.
Please go to the presentation mode and then you can start.
Can you see my screen, my presentation?
Yeah, it's visible.
Good morning, everyone, and thank you for the opportunity to present at this conference. My name is Armando Oliva, and I'm a PhD student at the National University of Ireland, Galway. Today, I'm going to present a part of my research work that concerns the effect of methanol organosol pretreatment on anaerobic digestion of lignocellulosic material. I will start with a background of renewable energy and with an overview of lignocellulosic material and pretreatment methods. Then I will go more into detail of the organosol pretreatment and the raw substrate I used for this study. I will show you my experimental setup and the results I got, and finally there will be conclusion and future perspectives. Despite the interest in renewable energy started about 50 years ago when the fossil fuels seemed to be depleting, the renewable energy accounted only 11% of total energy consumption in 2018. Thus, the world is not on track to limit global warming. For this reason, we are investing to develop new strategies for renewable energy production. And among us, methane production, biogas production is one of the most interesting. Firstly, because it produces few atmospheric pollutants per unit compared to fossil fuel, but also because an extensive pipeline distribution is already in place almost worldwide and especially in Europe. Despite this, the last World Bioenergy Association report states that we are exploiting only about 2% of the potential of anaerobic digestion. Lignocellulosic material, in particular, represents a good opportunity for biogas production through anaerobic digestion. They are the most abundant bioresource on the planet, and they can be taken as a waste from agricultural, municipal, and industrial activities, generally at low cost. Also, they do not create competition between food and energy production. Despite this, the use of lignocellulosic material for biogas production is still limited due to their complex structure that mainly is composed by extractive cellulose, hemicellulose, and lignin. Lignin and hemicellulose in particular create a physical barrier around the cellulose, reducing the biomethane potential of these substrates. In addition, crystallinity as well as polymerization of the degree of polymerization of cellulose and accessible surface area also limit the anaerobic digestion of these materials. Several pre-treatment methods can be applied to enhance the anaerobic digestion of lignocellulosic material. They can be classified in physical, chemical, physicochemical, and biological pre-treatment. In particular, my study are mainly focused on chemical pretreatment. In any case, the aim of all pretreatment is to increase the efficiency of lignocellulose hydrolysis, improving the accessibility to cellulose. This aim can be achieved by removing lignin and or cellulose and to decreasing the degree of polymerization and crystallinity of the cellulosic component of biomass. In this study, in particular, I used an organosol pretreatment. Organosol is a chemical pretreatment in which the solid substrate are mixed with an organic solvent with and without the presence of a catalyst. The aim of this pretreatment is lignocellulose is a lignin dissolution, leaving the cellulose and the hemicellulose in the solid phase. Also, depending of the pre-treatment condition, partial hemicellulose hydrolysis and increase of porosity can occur. In my case, I performed this pre-treatment on 3 different lignocellulosic substrates, which are hazelnut skin, spent coffee ground, and almond shell. Hazelnut skin is a typical waste from confectionery industry, and despite the skin represents only about 3% of the total weight of the fruit, it presents a high bulk density that can create several disposal problems. Of course, there is no need for an introduction for coffee. Coffee is the most consumed drinks all over the world, but what we must say is that about 50% of the fruit mass become a waste. Finally, almond is one of the most produced and consumed nuts in the world, and about 70% of the total weight is composed by the shell that, of course, become a waste. After this introduction, we can move to the experimental setup, starting with the pretreatment. I performed organosol pretreatment by using a 50% methanol solution with and without addition of sulfuric acid as a catalyst. Pretreatment was performed at under 30, under 60, and 200 degrees for 60 minutes by using a steel reactor in which 20 grams of the solid substrate and 200 ml of the solvent were mixed. After pretreatment, the treated substrate were washed with the distilled water and underwent anaerobic digestion. The biomethane potential batch tests were all carried out under mesophilic wet condition using a 250 ml serum bottle as a bioreactor. In this bottle, inoculum and substrate were mixed in a ratio of 1.5 grams in terms of VS, and distilled water was added to reach the final working volume of 150 ml. The biogas production was monitored with a pressure reader and the gas composition was analyzed with a gas chromatograph. Here we have the results in terms of methane production obtained from hazelnut skin pretreatment. From this graph, we can observe that all pretreatment conditions were significantly effective on the hazelnut skin. In fact, the raw material produced only a few ml of methane. Instead, all pretreatment conditions increased a lot the methane production. In particular, the optimal pretreatment condition was the methanol organosol pretreatment at under 30 degrees with catalyst addition that leads to an 18-fold increase of methane production. Also, by comparing the two graphs, we can observe how the catalyst addition enabled to gain a plus 15% of methane production compared to the best pretreatment condition without catalyst. These results are also supported by the scanning electron microscope image we can observe here. In fact, here we can see how after pretreatment, the cellulosic fibers are much more available compared to the raw substrate. Here we have the methane production from spent coffee ground and almond shell. In this case, we can see pretreatment was just slightly effective on spent coffee ground with a slight increase of methane yield. But in any case, this experiment showed the high biomethane potential of raw spent coffee ground. On the other hand, no biomethane yield enhancement was observed for almond shell after pretreatment, but an increase of methane content in biogas from 57 to 77% was observed when almond shell were pretreated at 200 degrees without catalyst addition during pretreatment. Here we can observe the effect of pretreatment on lignocellulosic composition before and after pretreatment. From this graph, first of all, we can notice the recalcitrant nature of the three row substrate. In fact, the total lignin content was 40%, 20%, and 31%, respectively for hazelnut skin, spent coffee grounds, and almond shell. On the other hand, the sugar content was significantly different between the three substrates. In fact, hazelnut skin shows only a 14% sugar content, mainly composed by glucan, which is the main cellulose sugar. On the other hand, spent coffee ground have a much higher sugar content of 42%, mainly composed by hemicellulose sugars such as mannan and galatan, with glucan being only around 9% of the total composition. Finally, almond shell show a more balanced composition between hemicellulose, cellulose, and total lignin, with the main hemicellulose sugar being xylan. After pretreatment, a lignin removal between 7 and 12% was observed from hazelnut skin, depending on the pretreatment condition, with sugar content increasing from 13.7 to 17.3%, showing a strong inverse correlation between lignin content and cumulative methane production. As regards spent coffee ground, only a slight increase of sugar content was observed with a maximum lignin removal of 10%. Finally, no significant effect was observed for almond shell after pretreatment. After showing these results, I would like to discuss about the reason why this pretreatment was not that effective on almond shell and spent coffee ground. Two main reasons why are, in our opinion, chemical composition and physical characteristics. Chemical composition mainly depending on lignin content and loss of non-structural compounds. In fact, since the main aim of organosol pretreatment is lignin removal, of course, this pretreatment is not expected to be that effective on a substrate poor in lignin, and this could be the case of spent coffee ground that had a 20% of lignin. But in our view, the main reason why of the failure of this pretreatment on spent coffee ground is the loss of non-structural compounds during pretreatment. These compounds, also called extractives, are mainly composed by not bonded sugar, such as sucrose, glucose, and fructose, that are also excellent substrates for anaerobic digestion. Another aspect we should consider is the physical characteristic of the three materials. In fact, based on the idea that if the solvent cannot enter the material, it cannot act, we measured the porosity of the substrate through the water swelling capacity. This analysis showed how almond shell has a much lower water swelling capacity compared to the other two substrates, and also the scanning electron microscope images confirm how almond shell is it's a very hard and compact material compared to spent coffee ground and hazelnut skin. Thus, the conclusion we can get from this study are that methanorganosol pretreatment was particularly effective to enhance biogas production from hazelnut skin, but just slightly effective for spent coffee ground and ineffective for almond shell. Also, the catalyst addition enabled to gain a higher methane production from hazelnut skin with the lower pretreatment temperature. The economic viability of this pretreatment for hazelnut skin was confirmed by the energy assessment with a net positive energy recovery of 1.35 kilowatt per hour per kilogram of ES, deriving from the extra biomethane produced under the optimal pretreatment condition. Here we have some idea to go on with this study. It will be interesting to maximize and optimize lignin recovery from pretreatment liquor, as well as to verify the economic viability of the recovery of valuable compounds before undergoing pretreatment and anaerobic digestion. Also, of course, further studies are required to explore different pretreatments able to raise the biomethane potential of spent coffee ground and almond shell. Thank you for your kind attention.
Okay, thank you very much, Armando, for your nice presentation. Now, session is open for the discussion. If anybody have any query, he or she can ask from Armando. Okay, so I have two doubts. In conclusion, you have written there is investment in terms of the biogas production. Can you tell something about in terms of the percentage, how much percentage of increase is possible?
Sorry, about the increase of audio is not good.
If you see your conclusion number, there is an increase in the biogas production to enhance the biogas production. First one. But
This one?
have you monitored anything? Yeah, the first one, if you see, to enhance the biogas production. First, your conclusion. Treatment was particularly effective to enhance the biogas production.
I'm sorry, I think there is some problem with the mic because the audio is very bad and I cannot hear nothing.
Yeah. Okay. My question is, now I'm audible? I am audible now?
Maybe it's better.
Okay, so my question is related to enhancement of biogas in terms of the percentage. What is your experience?
The percentage of methane in biogas, you mean?
Yeah.
Well, for these three substrates, I have to say it was around between 60 and 70% of biogas was methane. But the pretreatment did not enhance this ratio, except for the almond shell in one pretreatment condition. As regards spent coffee ground and hazelnut skin, especially for hazelnut skin, we saw a significant increase of total methane production, but the ratio methane to biogas was almost the same, always between 60 and 70%.
Okay. And the second, I have some query related to reaction time.
Yeah.
How much time is pre-treatment time, duration of pre-treatment?
Pre-treatment time was 60 minutes. This was mainly based on the the present literature, because a longer pre-treatment duration is reported to dissolve hemicellulose as well. That is also a good substrate for anaerobic digestion. So we wanted to avoid this loss of sugars. That's why the duration of pre-treatment is just 1 hour.
Okay, so thank you very much for your presentation. So I think
Thank you.
this is the last presentation for this session. So I would like to conclude these sessions. There are the total 5 presentation in this session. The first presentation is related to the how to control the odor in a compost barrel. This is by the Marcelino, and then followed by the presentation is the what is the role of the acclimatizations, how much time is required for the acclimatization in terms of the or ornamental parts, and the followed by presentation by or the role of the microbial culture in composting of the garden waste. So when we have a composting of the garden waste, how the microbial culture are playing a role. And then another presentation is specifically the SWAT model for the soil data parameterization. This is the field data as well as the theoretical data and comparison of that one. It's a lot more focus on the field study part. Then last, the presentation is related to the pre-treatment. What is the role of the effect of the methanol orgosoluble pre-treatment when we have a digestion of the lignocellulose material? So these are the total 5 presentation. I would like to thanks to all presenters who have presented and share their experience with the audience. So with this, I would like to hand over the session back to the organizers. Okay, so anybody from conference organization side who is listening me? Okay, so there is a no response from the organization side, any response from organizer. So I would like to bind up this session here, and I would like to thanks to the all participants for their sharing their experience, as well as organizer to giving me opportunities to chair these sessions. Thank you very much to one and all.
Thank you, sir.